First, just a little bit about me. I'm a software engineer in the TBN business unit, which is Technology, Business, and News. I'll show you a little bit more about that in a second. And I'm on the platform infrastructure team. Who are we at CBS Interactive? CBS Interactive used to be CNET Networks. We were acquired by CBS a couple of years ago. And we've got a number of different brands. Some of the larger brands are shown here. I am in the business unit on the far right, which is Tech, Business, and News. And the work that I'm talking about today was done as a pilot on basically the CNET brand itself. But everything that we were doing is fairly generic. And the intent is that after we validate with the pilot on CNET, we could leverage the technology that we're developing horizontally across the different business units. Oh, this thing's moving ahead on its own. A little bit more about CBS Interactive. We are a top 10 global web property. We have 235 million monthly uniques. We're already existing Hadoop users. We've been using Hadoop for a number of years now. Our data warehouse group uses Hadoop for a lot of its log processing. Our business unit has been using Hadoop for different applications like near real-time reporting. And we use a number of different technologies in the Hadoop ecosystem. We currently have 2 clusters. Our data warehouse cluster is 35 nodes. The TBN cluster is 6 nodes. It's actually outdated since I made these. That cluster has doubled. We're in the process of consolidating these clusters and doubling them. We should have about, that's really annoying, we should have about 100 nodes in our consolidated cluster in the next couple months. So to step back a little bit, what we're talking about today, basically we're developing a scalable, flexible platform that's going to provide the ability for us to aggregate large volumes of data, to mine it for meaningful relationships, and to then produce a graph of connected users and content. And from that, what we hope to do is to better understand the connections between our users, our assets, and our authors. I'll talk more about assets in a second. So the problem that we face currently is that users, when they're interacting with our site, they're always effectively voting on what it is that they're interested in with the actions that they take. They're clicking the got it, want it, or the got it link, or the want it link on CNET, or they're sharing, or following, or liking, or rating products on CNET. All these things are very indicative of what they're interested in. The other issue that we have is that users have multiple identities. We've got concepts of an anonymous user who is tracked with an anonymous ID in their cookie. We've got a concept of a registered user. When they're logged in, they're identified differently. And we have social identities as well. If the user is a Facebook user or uses another social site, we have different ways of identifying these users. We also have multiple devices. More and more people are accessing our site on different devices. So this creates challenges. Currently, we have a wealth of data that is siloized in these subgraphs in different parts of our organization. And so we've got this wealth of valuable user connectedness that's going unrealized, and we're striving to try to unify that in a single place and derive more value out of it. So then the goal of this project was to basically create a back-end platform that enables us to assemble a holistic graph of users and their connections to our content, our authors, each other, and themselves. When I talked about assets, assets is our generic way of referring to anything on our site that is publishable. So that could be videos or technology reviews on CNET or blog posts or news stories on news.com, and so on. Once we do this, we want to be able to better understand how our users connect to our content. And then we could use that information to then improve upon our content recommendations, our user segmentation, and our content and ad targeting. We do a lot of that already today, but the hope or the intent is that with this platform, we can improve upon how we do that. So when we set out to take on this work, we had a number of requirements that we had to work within. We had to integrate with our existing Hadoop infrastructure that I mentioned earlier. We needed a system that was going to allow us to aggregate data not only from within CBS Interactive, but also beyond, examples being Facebook or Twitter data. We needed to be able to connect the disjointed user identities that I mentioned earlier, so that when we looked up a user, we could say, this user is this person anonymously, and then they were registered on this session as this user, and they came to us on this device as this other user. We needed a flexible data model so that we could accommodate different data types from different assets of different brands that we have to support. And then ultimately, as I mentioned, we wanted to be able to assemble this graph of all the different relationships. And really at the heart of it, we wanted to be able to enable rapid experimentation, data mining, and hypothesis testing. We have all this data in one place. Product managers or engineers have theories that they want to test. They want to be able to quickly run different jobs, export the data, and see if there's any validity to the theories they're testing, whether it's A/B testing those features on the site or just validating them on their own. And ultimately, all of this is really intended to power new site features and advertising optimizations. So the approach, this is a simplified view of the approach. I'm going to talk more about each of these in a few minutes. Basically, 3 steps to this approach. Initially, we're going to mirror all the data that we could get our hands on around the organization into either HBase primarily, or in some cases just HDFS. Once we have the data, we're going to be able to use MapReduce to process this data, derive different relationships, and then ultimately we would export RDF triples of this data into a triple store. So the data flow. So if we walk this data flow through from left to right, you can see that we needed to be, what we're doing with the green area is we've got different sources of data. We've got live activity streams that come to us from a technology that we call the fire hose that's provided by our data warehouse group. That's a JMS queue of activity streams that happen on the front end site, and that's represented in green. We also have live publishing events that we could subscribe to as well. When content goes onto the site, we get alerts of that. And we could listen for that stream of data, and we could write atomic writes into HBase. In addition, we need to be able to do bulk writes or bulk loads into HDFS and into HBase. You can see, and that's what I'm showing here on the lower left-hand side with these different systems that we have. There's actually a typo. UCG should be UGC systems. But those are a couple of examples of systems that might load data into the system periodically in batch. So we got two different ways that data gets into the system. The batch data, then we use MapReduce to transform this data and load it directly into HBase, primarily using PIG, but also using import TSV in HBase, and I'll talk more about that in a moment. Once the data is all centralized, then we can run jobs then to produce the RDF that we export into a triple store. And once the data is in the triple store, then we could use Sparkle to do complex graph querying upon that data. And you notice that I have a generically shown triple store. We have not yet settled on what triple store we're using. We've been using different triple stores in our development efforts so far, but we still need to do a full evaluation on that, which is why I will be a little bit vague about that. We're also considering using more of a traditional graph store. So you might hear me talk about graph stores and triple stores. Some of the graph database vendors, the purists, might give me a hard time for bouncing between terms, but that's why. And so then ultimately we could surface this functionality on the front end of the site, but that's just one use case that I'm showing here. Along the way in the data pipeline, when we have this data in HBase and we have it all in HDFS, there are a lot of different avenues for exploring this data. Developers and analysts can have access to the data using MapReduce or directly going against HBase. And so there are many other use cases that will be able to be supported by using a pipeline like this. So this is a slide that I am borrowing from Emil Ephraim from Neo4j. He presented this last month at GlueCon, and I thought it had a lot of validity for what it was that we were developing. He's basically comparing the different NoSQL data models, comparing how data complexity relates to data size for different types of NoSQL solutions. And in the upper left-hand corner, he's got key value stores where you've got very high scalability in terms of your data size, relatively lower data complexity than compared to, say, a column family store. And then as you continue on, he shows document databases as well. You're getting more complexity, a little bit less scalability, and then ultimately graph databases in the lower right. Now, This plot is very subjective. You know, the slope of the line is arbitrary. There are no units of measurement on either of these axes. But I think he gets the point across well, and it leverages a lot of what we're trying to do. When we load data into HBase, we're basically working in that upper left-hand quadrant of this graph. As we then use MapReduce, we can then migrate down and leverage what we export into the graph database and then leverage the power as well of our graph databases. So we're trying to balance the ability, or I should say leverage the ability of both the upper left-hand quadrant and the lower quadrant of this graph. So what exactly are we talking about when we're talking about graphs and what data we're looking to store in the system? This is an example of a subgraph that we might get as we're listening to that fire hose that I was talking about earlier. As we're getting live activity events, we could build relationships in HBase where we could map that center node as an anonymous user, and we can say this anonymous user is also this registered user if we determine that there's a linkage between those two. We could also detect that this user has liked a certain asset of ours, or they followed another asset, or they followed another one. We can get these activities in real time, and we could write these directly into HBase. But where it gets a little bit more interesting, I was having fun with some of the transitions here as I figured out how to do them. We can then load in bulk or incrementally the CMS data that reflects what these assets actually are. So now we know that this asset that they're liking is also a tech product on the lower right, or other assets in the upper left, they might be following a brand of ours or following an author. We also know that authors of ours might author certain stories. But there's still a disconnect in this graph. If we're going to try and use this graph to traverse it for recommendations, for example, we need to be able to tie together our disparate different types of assets. So we can source data from another data source where we have our tagging systems. This is basically, we've got other systems that do content classification of our content, and we can source that data into the system, and that allows us to complete different pieces of these graphs, so we can say that this product also is tagged with the same tag as this story that might be on one of our news sites. So in doing this, we can then traverse through the graph and build recommendations. This is just an example, though, of some of the data that we're currently capturing in the graph. With working with graphs, we have a lot of flexibility, so we're able to store new types of data as new use cases emerge. And then also in the upper right, because we're integrating with our existing data warehouse Hadoop infrastructure, we also have the ability to join against more of our low-level atomic data at the end of the day, like different sessions that the user might have had, and what are the actual granular page events that they've actually taken. Up until this point, I've been talking primarily with all these likes and follows and these social events. Those are what we call our strong events, those strong actions that users say that they're interested in. The more lower level actions are basically page views, and we could interact with that as well. So how did we represent this in HBase? We used a number of different tables in HBase. We've got tables for assets and documents and tags. But the one that I'm going to talk about today is the user info table, which is really the key to all of it. It's fairly simple schema. It's got two column families. We've got the aliases column family and the event column family. And we represent the data in this table keyed to by the user identifier. And we've got different ways of identifying users, as I mentioned earlier. So in this example, what I'm showing is the anon user is an anonymous user ID with the prefix of anon. The URS user, URS stands for our user registration system, is how we identify a user who's logged in. When we see that event happen, we can store a bidirectional relationship in our user info table in the aliases column family. So this is showing that this user is the same identity for these different ways that we have to track them. And then in the events column family, when we see that they like something or they share something, for example, we store that where the column name in HBase is the prefix of the event type with appended to it the timestamp. So we could basically represent a one-to-many of user has many likes or shares or whatever other event we choose to track. And then the value of that event is basically a JSON blob, which represents all the different metadata that we were able to collect on the front end of the site when they actually took the event. Like what's the event ID, what site did it occur on, what's the asset ID, what's the asset type, the time it took, or the time it happened, things like that. There are other column families that we have in this table that I'm not showing. We're expanding upon this to have other column families like the user segment that we might put the user in when we do segmentation. But these are the core ones that we're using initially for the tracking. So we're using HBase to collect this data, and one of the reasons why HBase works really well for these use cases, as we heard a little bit earlier today as well, is it has support for both incremental and batch loading, which is key. We were able to consume off of our JMS fire hose and write into HBase in real time, which is critical. At the same time, we're able to support the batch use cases. In development, we use the HBase storage class from PIG, which has been working really well for us. What's nice about that is it's very easy for users to develop using that class. They could very quickly develop and iterate upon the different loading into HBase and exporting out of HBase that they want to do with that class. But there's also the import TSV functionality from HBase, which basically is a more efficient way of bulk loading data into HBase, because using import TSV, what it does is it creates H files in HDFS, which is the native storage format for HBase. Once it creates those in HDFS, you can then bulk load those directly into an active table. So generating RDF with PIG, for those who don't know, RDF is basically an XML standard that represents subject, predicate, object relationships. So if I like the iPod, the subject would be Bill, the predicate would be likes, and then the object is the iPod. And our philosophy around RDF is that we want to be able to store as much data as we possibly can in Hadoop, or Hadoop and HBase. Then we could be selective about what we want to export into our triple store. And that would be basically, we would decide what are the first class citizens that we want to elevate into the triple store. And that could be based on explicit to explicit relationships that we might have derived, or if we've done some sort of content recommendations or user segments that we might generate, related users, content tags. Or it could also be driven by what are our use cases? What are the things that we want, that we know we're going to be able to query upon or need to query upon for our recommendations? If the product managers say we need to do recommendations based on things that a user likes should be weighted stronger and things that they follow should be weighted a little bit differently, we could run jobs on that and we could decide that we want to export some of that information into RDF. And like I mentioned earlier, it makes it very easy, PIG makes it very easy to join across different data sets and create these RDF relationships. And then once that data is then in the triple store, we're able to then use Sparkle to query that. And for those who don't know Sparkle, Sparkle is basically an XML standard for querying RDF triples. Basically, you could write graph-like traversal queries, and I'll show an example of that in a minute. So this is just an example PIG script that generates RDF triples of users to the events that they've had. And I'm not going to go through all the details of this script, but the point is that it fits on one slide. It's fairly straightforward to do. Initially, we load the raw step. We basically load user IDs keyed to a map of their events. In A, we have to flatten those out. We have to massage that a little bit, and where we make bags out of the maps that we loaded. In B, we're able to convert the JSON data, that's that data representing what the event was on. We're able to convert that into a map. And then in C, we're actually able to look at what are the different events, or sorry, what are the different attributes and fields that we have for those events, and then we could act upon those. And then finally, at the end, we use a PIG UDF to hide all the nastiness of creating the triples themselves. And then we could export that and then import it into a triple store. Once it's in the data is in the triple store, we could write Sparkle queries like this. This is a bit of a contrived example. You know, if you're really going to do recommendations, there would be a lot more that would have to go into it, like edge weightings and things of that nature. But this just shows conceptually what we can do. This query, you could see, without getting into too much of the detail, what it's saying is that let's query for events where the event is a like. It happened on a social site. The site's called Facebook. And then we can traverse or effectively join from the asset to the tags that are associated with those assets. And then from the tags back to other assets which are not themselves, and then order that result by publish date, so the most recently published content is recommended first, and then we could return the title, the publish date, the tag name, so on. So in conclusion, there are a couple of things that we like about this, this platform, one of which is that it's very flexible. It's flexible with respect to how we model our data. HBase is inherently flexible. It gives you a lot of flexibility in terms of how you want to represent your data in the column family, in the columnar layout, as well as graph stores traditionally are going to be very flexible. As our use cases change, and we know that they will over time, we feel confident that we could represent different types of relationships, both in HBase, in HDFS, as well as in the graph store. It's also very flexible with the integration patterns. For every technology and data source that I showed up here, there are a number of different ways to get the data in and out, and I think that's going to be very valuable to us because the more options we have for our integration patterns, it's just more tools in our toolbox as our use cases evolve and change over time. Once the data is in the system, there are multiple options again for how you want to process this data or how do you want to query on this data. For graph traversal, we could use Sparkle. As I showed. We could traverse HBase directly if we've got all the different edges represented in HBase in the directions that we need to traverse. Or we could do we could run MapReduce jobs to do bulk traversals of the graph to then potentially export other pre-computed representations that might then go into the graph store. The other thing that we were trying to do with this, this platform is we were really trying to match the right tool for the job. Which alludes to what I was showing earlier in Emil's slide. Hadoop, obviously, it's known for its scale and computing horsepower, so we knew that that would make a great foundation for this platform to be built upon. HBase, it's very fast and allows atomic read-write access, very flexible for data modeling, also very scalable. RDF triple stores, there we're able to leverage the complex graph querying that you're able to do in a triple store. Pig, as I mentioned earlier, it's been very valuable for us just for very quick prototyping and iterating upon different MapReduce jobs that we might be writing, as well as ad hoc analytics. There's a whole other side of analytics that's kind of outside the scope of this talk, but we're also definitely looking to empower our analysts with more data at their exposure through this tool, or through this platform. In the future, there are a number of different technologies that I think will also lend itself very well to this system. HCatalog, we've heard a lot about that today. We're very anxiously awaiting that first release to give it a try. We think we'll get a lot of value there by being able to better manage all the different schemas and tables that we might be importing from different data sources. Uzi and Azkaban, basically we need to better manage all the different data flows. We need to have some sort of workflow engine. We've done quite a bit, or we've done some prototyping and development with Uzi, and that's been going well for us so far. We also would like to take a look at Azkaban at some point. Mahout for machine learning. We've already used Mahout quite a bit in some other groups in CBSI. I think that once this platform has centralized a lot of this data, it's only going to open up more options for us in terms of machine learning using Mahout. And even Hama, we're keeping a close eye on Hama. It's definitely very early in its development stages, but I think there's a lot of value there to have some sort of graph processing framework on top of HDFS, and it seems like every day it seems like we're hearing about more and more graph processing frameworks, and I think that this platform is definitely going to be interested in seeing those come out. There's the Giraffe talk this afternoon that I'm really eager to check out. And then finally, this is just a little, shout out to open source software. Working with the open source tools that we've been working with has been really great for us because as things don't do exactly what we want or we need some different needs, it's very easy for us to just contribute a patch, and now it's part of the code base and everybody in the community gets to benefit from it. So with that, I'll open it for any questions. So the question is, how do we handle when a user wants to opt out of data and not be tracked, basically? Yeah, that's a great question. We take that very seriously, and the current thinking is that when we allow a user to opt out, they will most likely opt out very early on in the stage. So where we're consuming off that fire hose of data and getting all those live activities of those users, the expectation right now is that we will just have a short circuit there, and we will just not get access to certain data from users who have opted out. We could also, if we have to go back retroactively and remove data, we would just have to write processes around doing that. But actually, this will make it easier to do that because once this system is in place, we will have a single place to go to get all the information about a user. Right now, it's everywhere.
Yeah, what functionality do you expect to get from the triple store that you could not get directly from HBase? I mean, why not just leave the graph in HBase?
Yeah, that's also a great question. The triple store, what we're looking at the triple store is to see if we can get low latency, complex graph querying that could eventually power our front-end site. We're hesitant about putting HBase in front of our front-end sites currently, just because of issues around pauses during compaction or potentially garbage collection. And so we're looking to see if the triple store could be more of a refined set of authoritative data that could be exposed to the front end. But that's all with the caveat that we can get the performance out of it that we need.
Quick question. You mentioned correlating an anonymous user ID with a registered user on your site. Any details on how you go about doing that?
Yeah. When we have tracking on our site, I mean, the answer is pretty basic. It's, you know, when we see a co-occurrence of both an anonymous, users always have an anonymous cookie. And so we always should see that. But when they log in, we'll see another logged in identifier in the tracking information that we get. And so that helps us to do that correlation. Where we have a harder time doing that correlation is when we start looking at mobile devices. And that's something that we don't have a solid solution on yet, but we're looking into it. I mean, without getting somebody to log in on their mobile device, it's very difficult for us to, or actually impossible for us to currently connect the anonymous user on the mobile device to the anonymous user on the site without some sort of UUID or something like that on the mobile device.
Cool, thanks.
Yep.
Just a quick question. Do you use upsert functionality in HBase, like upserts, increments, inline increments, like counters and stuff? You know, like in MongoDB, you have something like that.
Right.
You know, HBase has a very similar functionality. I'm just curious. We use MongoDB heavily, not using HBase yet, so I'm just curious if you tried comparing or how that works.
So you're asking if we've used functionality like inserts, things besides just puts?
Right, yeah, there is functionality that you can upsert, like perform an upsert. If a value is not in, you know, the column, then it would either insert it or increment it, for example, inline.
Yeah, we're not doing any of that.
Okay.
Everything we're doing is just writes, primarily writes of new data. That's all atomic records that we want to insert and have persistent after that.
Okay, thanks.